Welcome, y'all, back to some more geometry. In this section, we are talking about proportions and ratios and just similar things. For example, similar polygons, similar triangles, many things. But first, let's talk about ratios and proportion and what are they, how are they, so on and so forth. So let's start out with what the word ratio is. So we've heard ratio before, but what is it really? A ratio is, of course, a relationship between two numbers. Two or more, really, as we'll talk about here in a bit too, as well, but two numbers. Now, as it says right here, it says it can be set as a quotient. Now, remember, quotient is the fancy math term for division. So ratios are kind of a form of division here, but you're not only dividing. There's many other things you will do. So as is shown right here, you have a ratio of A to B, and then you have a ratio of A colon B, and then A over B. Okay, those are all right there different types of writing a ratio. None of them are wrong, and as you can see, a division or a fraction is a ratio. It's a type of ratio right there. All right, so for example here, we're going to write the ratio 4 to 6. We're going to write it in different ways. So let's kind of look at that. So we're going to write it in all three different ways. We're going to write, let me get my pen. We're going to write it as 4 to 6. That's one way of doing it. Or you can write it as 4 colon 6 or 4 over 6. Now, these are all proper ways to write this. But let's not forget, y'all. Also, I did write written wrong. My bad. We can reduce these as well. These can also be reduced, just like a fraction right here that we're used to. These also can be reduced. So this will be the final answer for these will be 2 to 3, 2 colon 3, or 2 over 3. These are all perfect examples right here. Now, an extended ratio is, again, a relationship between numbers of 3 or more. In your case, we're only going to deal with 3 at the most. We're not going to do anything beyond that. So just kind of look at an example of that right here. So, hey, the ratio of the measure of the angles in a triangle is 3 to 4 to 5. Find the measure of the angles. Now, they're telling you that when we compared all three angles right here, they all eventually reduce down to 3, 4, 5. So our goal is to kind of find what were the original three angles here. So because when you do a reduction, for example, over here, when we reduced 2 to 6 down to this, we reduced it by the same amount both sides, by 2. So 2x to 3x, the x being how much we reduced it by to get back the original ratio. We reduced it by 2, so we multiply those, we got 4 to 6. So the idea is same here. So when we talk about, hey, we have three angles that add up to each number. So it's a triangle. What do all three angles add up to be, class? Yeah, 180. So how can we turn this into some sort of equation? Well, we put x's with them. 3x plus 4x plus 5x will equal 180. Those are the values of these parts. So 3x, 4x, 5x right there. It's a ratio of 3 to 4 to 5 right here. Okay, so this is what it was. These are now set as an equation, so let's kind of solve that. So 3 plus 4 plus 5, that gives us 12x. 12x equals 180. We divide by 12. What did we get, y'all? I think it's 15, right? Let me double check. I want to do some improper math on here. Right here. There you go. 180 divided by 12. Yeah, 15. Our x value equals 15. Now, that's the value of x. Here's a problem, and this is a problem that we keep having sometimes as we do our work. We find the value of x and we call it good, but that's not the question. It's not asking how much did it get reduced by, what's the ratio, the scale factor here. No, they're asking what's the measurement of the angles, all three angles. So to figure that out, we're going to substitute them all back in here. So 3 times 15, we get 45. 4 times 15, we get 60. And then 5 times 15, we get 75. So these are the three angles right here, 45, 60, and 70 degrees. This is what we're looking for, y'all. Okay? So let's do the same thing, but this time we're going to deal with the fraction. The fraction here. Now, there's two ways to do this. We're going to do it one way, and then I'm going to go back and do it the other way to see which one you kind of prefer the most. Now, to me, what I'm doing, it's still the same idea. There's still a value of x with all these, so they got reduced to this amount. So it's saying the ratio measure of the three sides of a triangle is 1.75 feet. Find the length of the longest side right there. And we're going to go to the nearest one decimal. So this will have a decimal answer, and it'll tell you on your homework assignment to the nearest 10, nearest 100. It'll tell you where to round it. But if it doesn't tell you, we're gonna go one decimal. Always go one decimal in this case. So like x dot x. Okay. So same idea. We have an x value. So x over 4 plus x over 8 plus x over 6 equals our perimeter 4.75. All right. So to me, this is my preference. I think it seems the easiest. Let's just get rid of the denominator. What will get rid of the denominator? Will just give us something to divide into. So what's the common number between 4 and 8? What's the common multiple? So what's the first number all three have in common? When you're dividing. So or I guess multiplying. It's a multiple. We're looking for the least common multiple. So we're looking for a bigger number that they all can divide into. In this case, it's what class? 24. Yeah. We're going to multiply 24 to all four of these things right here. All right. So 24 times x over 4. 4 goes in 24 6 times. Give me a remainder 6 times x. 8 goes in 24 3 times. So we get 3 times the x. And then 6 goes in 24 4 times. Give me 4 times x. And that equals, we take 4.75 as well times 24. It gives us the number 114. Now we put it all together, we get 13x equals 114. We divide by 13 for both sides to solve for x. We get x equals 8.76. Now we're gonna go 3 decimals for now because we're not gonna round it yet. We'll go one more, 2, just to be safe. 4 numbers. Now we're looking for the longest side. So of these 3 fractions, which one's the longest? The 1/4, 1/8, or 1/6? Well, if you remember our fractions, the smaller denominator, the smaller the pieces is breaking it up into. So 1/4 is bigger than the other 2. So we're going to take this x over 4 and we're going to substitute that in there. All right, so 8.7692 over 4 is the longest side. So let's go ahead and actually divide that. You divide that, you get 2.192. We're going to go ahead and round to the nearest one decimal. So that's a 1. We look at the number next to it. That's a 9. So that rounds that up to 2.2 feet. This is the longest side. So remember, just because we find the x does not mean that's our final answer. This is the answer we're looking for ultimately. Now, the other way you can go about this as we're talking, let me kind of clear this off. You haven't seen it. The other way we can go about this is, we can leave it in fraction form and just get a common denominator. So 1/4, x over 4, x over 8, plus x over 6 equals 4.75. So the common denominator is 24. So then we're going to multiply everything to make it all common here. So we'll multiply this by 6 over 6, this by 3 over 3, and this by 4 over 4. When we do that, we end up getting 6x over 24 plus 3x over 24 plus 4x over 24. And we leave this alone. We don't reduce this. It's 4.75. We add these up. We end up getting 13x over 24 equals 4.75. And then again, to solve for x, we multiply by the reciprocal, which would be 24 over 13 on both sides. 24, so times 24 over 13. So when we do this, we'll take 4.75 times 24 and then divide by 13. We still get the same answer. 8 points. What is it? Ooh, let me double. Times 4. 8.7692. That's what we get. We still get the same thing for x regardless. I think to me, not having the fractions is a little bit easier. But either way is right. All right, so let's look at a couple more things. So when we're talking about ratios, it's all about the wording they say. This is very specific. It says, what is the ratio of length to width? If we don't know the difference, remember, length is the long side, width is the wide side. So length, we're comparing length to width. What is the ratio of length to width? What is the final answer? Not just what's the ratio, what's the final ratio? Final ratio is 4 to 1. The question is, why is it 4 to 1? Because remember, we're comparing length to width is 24 to 6. But remember, if you can reduce it, reduce it. Both sides reduce by 6, or reduce it, we get 4 to 1. Now, what's the ratio of width to length? Find the ratio, 1 to 4. Now, see the difference here? It's all about what they're asking. What are we comparing? This to this, this to this. So that's how you'll write it here. So here, what is the ratio of x to y? So the value of x, talking about the angle, this is 45 degrees. Now this is a parallelogram, so adjacent sides, adjacent angles are supplementary. So what will be this angle right here? 135. Yeah. Good job, class. It's 135. Now, so as we write this, we'll say, hey, so what we want to say, all right, so what's 45 to 135? Yes and no. This is a ratio, but it's not the final ratio. They do reduce. These actually both sides reduce by 45. You get a 1 to 3 ratio. Yeah. What is the ratio of W to Z? Now remember, this is a parallelogram, so opposite sides are congruent. Opposite angles are congruent. So that's 135. This is 45. So then, what will be the ratio W to Z? It will be 3 to 1. And what about W to Y? 135 to 135. What does that reduce to? 1 to 1. Yes, 1 to 1. 1 to 1 is what we consider a perfect match, when things are 1 to 1 to each other. All right, so that's ratio. Now let's talk about proportions. Now you've done proportion before, specifically these type of proportions, when you're doing these type of proportions. Now in proportion, the first and the last terms are what we call the extremes. They tend to be the biggest and smallest number in a set of, in a ratio. The middle terms are called the means because they're closer to the average right here. So for example, these are the extremes and these are the means. The first and last one are the extremes, and the two in the middle are the means. Again, now this one's a different thing right here. So the first two are the means, and second two, first two the extremes, second two the means. This, and we'll see why this looks like this. This is actually this, but simplified. Now, the mean extreme property is pretty much what we do in math before we do cross multiplying. Let's say you have an unknown. When we cross multiply, we multiply these two and say they're equal to these two. The extremes equal the means in this case. So the extreme mean property is saying, hey, if you multiply the first and last one, that should equal the value of the two middle terms multiply. So when you do A times D, you get A times D equals B times C, or this right here. This is what ultimately gets. So let's kind of practice that, the extreme mean value here. So to solve for the value of x, these two are our extremes, and then these two right here are our means. So we still then do a cross multiplication. So we take extreme times extreme, so 5 times x equals the mean times the mean. 3 times 6, 2, sorry. So we get 5 times x, just 5x. 3 times 2 is 6. We divide by 5. The value of x equals 6 over 5. Or what would that be? 1.2? Yeah, 1.2. Okay, same thing here. Mean times extremes. So these are extremes and these are our means right here. So 4 times 6 equals A times T. So 4 times 6 is again, 9. Sorry, I said 6, 9. That is 4 times 9 is 36. That equals 8 times T. Divide by 8 on both sides. What is that? That'll be, I think, 4.5, right? 36, no, yeah, divided by 8, yeah, 4.5. You get 4.5 equals T. All right, same thing over here, y'all. Extreme times mean. You tell me what this is. Okay, take pause and do these last two. I want you to do these last two. This one you're gonna solve for x. This one you're just gonna set it up. Okay, so pause, take a second. All right, so you should have done this and you just cross multiply. You get 3x equals 2y. Can we do anything past that? No. So you just did it, and you're right here. Now this right here is telling you to solve for it. So we're still gonna multiply extreme times the mean. So extremes, 3 times x plus 3 equals 2 times 2x minus 1. So part of this is we gotta make sure we distribute. So one thing we forget to do, so we get 3x plus 9 equals distribute to, oh, sorry, I said 2, it's 4. 4x minus 2. All right, so since this x is bigger over here, we're going to move this side, 3x minus 3x, and then plus 2, plus 2. We're going to get 11 equals x, and that's our value for x. This time we are solving for x, so be mindful of that. But hopefully that helps you out. That's what today's lesson's about, ratios and properties, and y'all have a great day. Bye.